Hello, this is Frank Witmer with Brody Precision and bringing to you today another session on CCT. Today's topic will be connections and logic. In CCT, you could have the logic display on the top part of the screen and see connections at the bottom, and then we can see how they interact. So if we're on our logic at the top, you'll see that this wire sheet space, yellow is input designations, and these are called activity inputs. And you'll see over in this palette, there's activity inputs and activity outputs. These are the slots that you're adding to be able to connect to external or network input, network output points, and physical input and outputs. That's where you'll be pulling in the data for the logic to work with. And if we look at the bottom part of the screen, you'll see down here this logic. It's called hot water reset by OAT. You have your inputs and you have your outputs. And again, the inputs are yellow, outputs are that blue cyan color. And you'll see the hot water set point is a output of the of this piece of logic, and the connections again to the real world are done through connections at the bottom. On the connections, basically the way they work is in the center, wherever you have focus on from the upper section. On the input side, if you right click on any of the slots, you'll come up with a new connection, or if there's a connection already in place, it'll be change connection and break connection. And the same applies to the output side as well. And what comes up then is a select the reference. So on the output side, it'll give you a list of available points to be able to link to. And if they are compatible units, you'll be able to select one, and then all the way to the right is where you would pick which input slot of that does it connect to. And then the same on the input side, when you do that right click and you go to make a connection or you change a connection, it'll give you a list of all the available points, and if they match up with the type of link you're making, they will appear on the right side and you'll be able to make that connection. One key point here is in order for these links to work, these connections to work, is the the display units, have to match. So you have, if you're an off-on or a normal alarm type point, that's an enum, and the Boolean type is inactive-active, which is really just true and false. So in order to connect, you would have to make sure that they do match, and you'll know that because they'll be available or not available if they match or don't match. So example here is we're going to create a new logic module. We'll call it OA reset set point. First thing you would do in your logic section is you're going to be creating a new module. And this new module is going to be an activity module, and basically that'll give you a blank wire sheet to which you build your logic. So here we would select, we're going to do one new activity module, and we'll call it OA reset set point. We click finish, and then it would open up on the screen. And my second shot here is showing a couple of the components pulling out of the palette. We have our inputs and we have our outputs. Again, they're activity inputs and activity outputs. And for our example here, we're using input float types, and we're using a output float type for the activity output. And the span block is actually the reset block to do our outside air reset. So basically, once you have those inputs and outputs in place and you have your modules or your components in there, you link between them, and it's basically just left click on the output of your input activity slot or object, or the output of an object, to the input of where you want to go. You just left click and then left click again on which input you want. Same thing on the outputs. You would click where it says present value. You click on the left side of this activity output, and it would make the link. It's that simple. Once you're done with that, you want to connect your logic to the inputs and outputs that you've put together on your application. And in this case here, we needed to add a network output called network output hot water set point. That's what we need to connect to the that activity output that we had created in the logic. So once we do that, we select our module that we want to do our connection to. We're in the connection tab at the bottom, and you'll see your inputs and your outputs. If you right click on your slots, it'll come up with that select reference that I showed in an earlier slide. And then you would choose, in this case, OAT, and it gives you the ability to then there's an output slot called O1. We click on that and it would make the link to this input. Same thing follows suit on the output. We have this effective hot water set point that we want to link. So we would right click there, say make connection, choose the network output point that we created, and then you, on the right side of that, you select that slot, click OK, and we've made our connections. And as you can see on this screenshot right here, you have over here on the left side here, as I mentioned, you have your input OAT is linked to the input slot of our module we created to OAT, and the output slot is connected to the actual network output that we had created in there. Now what I'd like to do is take you through live in CCT, and we'll basically build the same application and then do a few more things with that. So here we have our CCT open, and what we're going to do is we're going to create a new application, and we're just going to start with a totally blank custom application this time. So what we'll do is go to new, and then we'll create a name. We'll just call this logic class, and we're going to choose custom application and click OK. And what comes up is the system selection wizard that we've been through before. And what we're going to add today are, we're going to add 2 zone temperature sensors. What I think we'll do is do a quick temperature averaging to show how you could do something like that. And then we want our outside air temperature sensor. We'll click OK and move on. And now when the application gets built, we're going to see that we have, let me bring that back over here, and relink it up. Reset the screen there, and basically we have a physical outside air temperature and 2 space sensors. And what I want to do is, as we know, we're going to be doing a outside air reset to start. So we're going to go ahead and create a network point that we will call. First, we're going to choose we're going to do a float point, and this will be our effective hot water set point. So we'll leave it at that. So we have that point created there. The yellow triangle is showing that, or the orange triangle is showing that we don't have any logic attached to it. So the next step is we are going to create a new logic module. So I'm going to right click there and say new. And from there, we want to scroll down and find activity. So we're doing an activity module, and we're going to call this one OA, I'm just going to call it OA reset. So now we have the OA reset module showing up under output control. If we click on that and we go to our logic screen, we will see that, and we can actually, with this icon in the corner, we can go full screen or we can go back. So we'll go full screen, and we'll move this around a little bit, and we'll start out by adding our activity points. We want our input and output slots. So if we put in our input slot, the first one, we'll zoom in so we can see it a little better. This one here, I'll hit F2, and we'll call it OA temp. And then we also need our 4 settings for the reset. So we know what the how to control. We basically want to do is take outside air temperature, we'll say between 35 degrees and 65 degrees, and we want to have our hot water set point be 180 degrees down to 120 degrees. So we need to add some more of these floating inputs. So I'm going to do is just say duplicate and bring that down here, and then we'll call this one. This one will be our OA temp low value. And what we can do is go into the detail sheet for that, and I'm going to make its default value 35 degrees. So apply, close that, and then we will duplicate that one, and we'll make this one the high value. And then we can copy these two. These will be our set point boundaries, the high and low set points that we want to go to. So we'll make a change on this one, and we'll call this one we'll call it hot water low set point. And we'll make that change. At the low set point, we want it to be 120, the low end. And we will do the same thing here. We'll edit the name a little differently. We'll do it from in here. Hot water high set point. And we'll make this one 180 degrees. Close that. So we've got those inputs. We also need our activity output, which is our effective set point. So we'll do our F2. Click on that F2, and we'll call this our effective hot water set point. Now we need our span block, and that is going to be under calculation. We take our span block and we bring it in here. And what we want to do is we want to go in there, and we're going to be connecting to some slots in here. So what we want to do is we want to right click, we want to expose our ports to be able to do our connections. So we want our input range and our output range to be exposed. So now we have those there, and what we can do is say, okay, we want to connect outside air temperature to the input. So there we're just going to left click at the end, and then left click on input. Outside air temp low value will go there, high value will go there, low set point will go there, high set point will go there, and present value will be the reset set point, so it's going to go there. So we'll go ahead and we've got that. Now what we can do is we can do a quick simulate and test to see that this actually is all connected up properly. So I'll save that, and then we'll start simulation. One thing in simulation, it allows us to be able to go in and override our inputs, so we can run it through its paces and see how that works. So if we have our command here, and we'll say our outside air temperature is 35 degrees, send that. Oh, I didn't go in and we didn't change our high setting. So we want to change our high outside air value to 65. That's why we had that error with the red one there. So now at 35 degrees outside, it is 120 inside, or I'm sorry, with 35 degrees outside air temperature, it's saying our effective set point is 120. So what I'm expecting to see is if we command this to 65, we're going to see that it's going to go to 180 at that point, which is total opposite of what we want. That's why we test our applications. So do you want to save what you made? Yes. So what that means is we have these two backwards. So we're going to go ahead and delete them. The links there will go in here like this. We'll link there to there, there to there, and simulate one more time. we should know right away if it's working, because it'll go to 0 degrees for the outside air temperature. We should be at 180, which we are. So now if we say, okay, it's a nice warm day outside, we'll make it 70 degrees. It should reset down to 120, which it did, and it's working the way it should. So now we know our application or our logic is correct, so we can go ahead and stop simulation. So we have a completed logic here, so we can go ahead and go back to our control view, and if we go to connections, make sure OA reset is selected. We have our inputs and we have our outputs, so we need to make the connections on here. A couple things here. One is a simple one, OA temp. If we right click on that and make connection, we have our OA temperature right there. Output 1 slot, connect, it made that connection. We can do the same thing on the effective hot water set point. Make a connection. We want this one here, and we want to go there. So we say OK and made that connection. Now we have something we have to decide on what we want to do. If we leave it as is, these are going to be 4 internal settings or parameters for your outside air reset. I would think you're better off making them network points so that they can be commanded across the network, say from a JACE, some network management device. So really what we want to do is we're going to need to make 4 network inputs to represent these values. So we can come over here and say new. And here we want to create 4 new network inputs. We'll say finish. So there's our 4 inputs there. So we'll just go through here and double click. We'll make this one the OA temp low will be the value, and we'll make that 35. So apply, close. We'll do this one here as our OA temp high value, which will be, oh, I messed that up, OA temp high value, and that one's going to be 65. Say apply, close that, and we go to the next one. These are going to be our hot water set points. So here it's going to be hot water low set point, and our low set point we want at 120. Say apply, and we do this one here, and we say this one will be our hot water high set point. Make that 180. Apply that. We can close, and we have the 4 there. And again, they have these triangles telling us that they're not connected yet. So what we want to do is go back, connect, or link, or select our output control OA reset module. And there's our 4 points we want to link. So we'll do the first one here, our low value. So that would be low there, okay. The same thing here, make connection, our high, got that. Go here, our hot water low set point, our hot water high set point. So now they're all linked. And as I mentioned, doing this then allows these values or these points to be linked and integrated back to a JACE or some other network management device. So if we look at any one of these, you'll see that they are set up as a backnet point, and you'll see here it's an analog value, and its address is 10,028. That's the same for all 4 of these points. So there you have a completed logic loop where you've made your connections and you have your inputs and outputs for that. Now, let's say for some reason you choose that you have outside air temperatures actually coming from a different controller. So this internal one, this physical OA temp isn't good enough for you, and or isn't going to allow you to make that connection. You want to have a good value for outside air temperature since it's across the network. So what we could do is we could come in and say, okay, pick a new network input, and we'll call make it a float, and we'll call this one network input OA temp. So that then it could be a backnet point that you get its value from somewhere else. So now that we have, oh, there it is right there. When we take that, if we go back to our logic, we're connected right now to the physical point. If you want to change that reference, we would come in here, right click on OA temp, change connection. And it'll come up and allow us to make a change. So where do we want to get it from? We want a network input, and we want OA temp. And we make that change, and it's done. And you download, everything's ready to go. The second part of this I wanted to do was just another logic loop, a logic wire sheet. This time we're going to do one, and we're just going to call this one average temperature. Bring that over here. Again, it's going to be a activity module, and this one will be, I'm just going to call it average temp. Finish. So now we have this module, which will be a logic wire sheet. And over here, we want to create a network point so we can display the average temperature. So here we'll go in and say average room temp. Finish. So we've got that there. So we can come in, select average temp module, go to logic. And again, we're on the logic sheet, and we want to bring in our activity inputs and outputs. In the case here, we have two room temperature points that we want to do. So if I go on this one, F2, and bring that over here, and we'll call this room 1 temp, and duplicate that, and we'll make that change. We'll call it room 2 temp, and then we need an output for our logic. So there we will go and choose a output float, and in there we will call it average room temp. So now all we need is a averaging block, and we should be off to the races. So if we come down here and go to control, or I guess it would be math. Let's see, where is average? Maybe it's statistical. There it is. Okay. So average is under statistical, not math. So we'll go bring that out here, make our links. And we could simulate it, see the changes. And let's say we got 72 and 75, or so you start simulation. We just want to see what our output does. So now we don't have links to those points, so that didn't do us any good setting those values up ahead of time because we didn't do our connections. So we'll say, okay, room temp 1 is 72, and then we'll say room temp 2 is 75, and you'll see 73.5, so it works as we'd expect. We can get out of simulate. And the next step is to go back to the connections, select average temp, and here we're going to say make connection for room temp 1, and that's going to be zone 1 temp. This one here will be zone 2 temp. And our average temp, we want to go to that network output point so we can display what the average temperature is. And from there, this could be used in another part of our application if we wanted to. So that's just a couple examples, simple examples of how to create logic and also working with connections. Thank you for your time.